Hey everyone, and welcome back to another episode of the Works Plus grinder machine videos. Now, today we are going to be having part 2 of the head conversation. Part 1 was really good, invigorating, until the part where I fell asleep. But today is actually going to be a whole lot more exciting because they're going to be showing us the head. Stay tuned and have a look. This is going to be fun.
Over here and have a look at, we've got a few belts sitting over here. So just for those people that have not actually pulled a machine open before, so here's a good example of a PolyV or a MicroV belt.
Yep.
Okay. This one's a double-sided one, so you can see it's got the MicroV profile on both sides. What's good about these belts? Why would a manufacturer choose a MicroV belt? There's obviously reasons why these things exist.
Two reasons that I know of. One is the anticipation that takes away tracking.
So actually keeping it on the pulleys. Yep.
The other theory behind it is surface area. You have more surface area because you're corrugating that surface. So
and therefore you don't need as wide belts either, right? So it's because of the zigzag. If you were to straighten that out, you got a much wider belt essentially, but it's compressed because of that zigzag texture.
Yeah.
Therefore you can have narrower pulleys, yet still have the same surface area.
Yep. Correct. They're the main two I know.
And grip. Yeah, and grip. So as that belt's tension, the V's basically get pulled deeper into the V profile on the pulley and create more friction or more grip that way, right? So they're the plus. The advantages to a PolyV belt. There's some good advantages to that.
There. Yep.
Let's talk about why we've stuck with a flat belt then over, say, a PolyV.
One reason is heat. These belts aren't rated to the same heat ratings generally as what they are. And flexibility of going around pulleys as well. You're what they call the wrap, the minimum diameter you can wrap around, probably isn't as tight as what you can get on some of the flat belts.
Fun fact, the very first 5 machines we actually manufactured in King Concepts had PolyV belts. Right. And the whole reason we chose them is because we didn't want to have to worry about the tracking issue and trying to get a flat belt staying on pulleys. Because we had problems with that when we had HTC machines. We thought, here's a good way of getting rid of this problem. Let's go to a PolyV. And therefore we could make narrower pulleys and not have to worry about the tracking.
I mean, other downfalls of some of this is your fly pulley manufacturing as well. Similar to the gears, you've got grooves and everything. It's a lot more of a process to have them made.
Yes, so expensive parts to make. Some of the other downfalls, like you've mentioned temperature. Now, look, to give you a comparison, certainly in our experience when we were running PolyVs in the King Concepts machines, most of these belts are made to a maximum temperature between, say, 70, maybe 80 degrees Celsius. And funnily enough, we were finding the machines were running around 60 to 65 degrees. And of course, once you start getting breakdown in bearings and so forth, they become more inefficient again, generate more temperature, and all of a sudden we're running a machine or the belt's going around pulleys that are higher than its temperature rating, and they're starting to disintegrate. So for us, at least on our machines, the operating temperature of the machine was just too close to the temperature rating in the belt. And we just started seeing failure after failure after failure. And we changed different brands and we still kept on coming across the same problem. So those first 5 machines, we ended up having to retrofit to flat belts. And I think at least 3 of them were in New Zealand, and 2 were in New South Wales. So, and one in, I'm actually up to 6 now, there's 1 in Queensland as well. So that was part of the experience that we had with the flat belts. The other thing I don't like about this type of belt is their strength comes from fibres. Okay, so let's just talk a little bit about these flat belts. So in comparison, this product has, I think, 120 or at least 120 degrees Celsius from a temperature range point of view. So way outside or way above, let's call it that, the maximum operating temperature of the machine. So if you want to talk about safety margin or safety factor when it comes to temperature, I have a lot of comfort when I'm using something like this, knowing that we're not sitting round about the threshold of the material. We've got plenty of up our sleeve. So when it comes to temperature rating, there's no comparison. Talking about the fibre reinforcement, obviously with these types of belts, you've got to be very careful with how tight. These types of belt I'm talking about, these rubber fibre reinforced products, lots of fibres, okay? As soon as you over tension or stretch them further than they're supposed to, you start to break down fibres, okay? And once you break fibres, you start losing strength, okay? This type of material is essentially, as one of our very much loved customers likes to describe them as rubber bands, okay? Elastic band belts. Barton, if you're watching, shout out to you. But there's a lot of truth in that, okay? The polyamide, it's a synthetic core, actually is like a rubber band. And I think these will actually can be stretched up to about 2% of their actual length. And they'll still
come back to
return back to their original length, okay? So once you start stretching past that, you get into plastic fatigue where they won't start coming back again. But you can actually put a lot of stretch into these things without breaking fibres and having that problem where you start losing strength in the belt. You were talking before about machines hitting obstacles, hazards in the floor, and that shock, okay, that shock. Again, you may have not over-tensioned that belt. That may be running the right tension, but as soon as it hits something hard like that and gets that shock through it, it is going to stretch, and you are going to over-tension the belt through the application, not actually through the manufacture or the construction of the machine. So you can actually start breaking fibres down, even though the belt's been set to the right tension
through day-to-day operation,
just through the use of the machine. So. That's not a manufacturer and installation issue. That's an actual user. And of course, if you've got no idea what belt you've got in your machine and these sorts of things, you're going to push the thing as hard as you can because that's what you're supposed to do.
That's right.
So another sort of reason why we're not particularly keen on the fibre reinforced PolyV type timing belt type product.
So I guess, from my knowledge on these, I don't see any joins on this.
Well, I was going to say, tell me what are the downsides of using a flat belt?
The downsides.
Yeah, we've talked about the strength and the weaknesses of those. They last too long.
Sorry, it's not for service. Sorry.
I'm going to come back to that quote. They last too long, but keep going.
Look, from a failure perspective, probably the biggest thing I see on these is because you have a join, there is a chance of having an impact break on the join from that exact same application that we're talking about. My guess, and I'm no mathematician here, but my guess is it's going to be a much bigger impact to break that belt versus what that's going to take by a long shot. The second biggest one is we see burnout on the centre drive pulley, which is usually from not having enough tension, which these...
Traction related.
Yeah, so these can hide that a little bit, but you're probably going to find that your day-to-day run-in is going to chew the entire belt eventually from doing that, whereas this will slip on just the centre drive pulley and basically burn through it if it's not enough. So that's going to give you an instant telltale that there's a problem. This is going to go for a little bit longer, but then disintegrate anyway. So still no real big difference on those that they're going to have. They're the main two I know of from serviceability side of things.
Yeah, so if we talk about join quickly, the join's the weakest part in that these belts are made in a mould, so there is no join.
One continuous.
One continuous product. These are made from basically a sheet of material. So the benefit of that is we can make a custom size and width belt. We can almost make them to whatever length we want, to the millimetre. We can make them to the width, whereas when it comes to something like this,
it's off the shelf.
It's off the shelf, set sizes. The only width variation is by how many ribs you want on it.
How many you can
and
cut
of
out.
course, if you can't get the exact size that you want, length, because they're all made in set sizes, you got to introduce more idler pulleys or have more range on your tensioner or something like that.
To adjust.
So a little bit more limiting from a freedom of engineering point of view. But clearly the join this is a very, very strong material. So from a tensile strength point of view, it's very high, even in comparison to this type of stuff. But the join is the weak. However, we've been making these belts for 25 years.
It's not that often we see it.
And we actually have some, let's call it IP in the manufacturing of the joins. So we make our joins, we have the manufacturer make our joins differently
to anyone else.
Well, even to what the manufacturer of the material specifies.
Yep.
So it's kind of like there's a standard specification for how to join these things, and then there's the way that we get them joined.
Yep.
Okay, which obviously strengthens that weakest part of the belt and just gives us more comfort to the lifetime.
Yep.
The owner of HTC once said to me, and I'll never forget this, he said, because we were having all these belt issues, and it came back to the sorts of things you're talking about. There was moisture getting into the machine, there was dust getting into the machine. You got two flat surfaces, you get talcum powder in between it, or you get moisture, you start to get slippage, okay, which this, like you mentioned, rightly hides a lot more. So as soon as it starts getting slippage, and you get burned through on your belt. Part of that was because the HTC didn't have enough belt wrap around the centre drive pulley, so it could never get enough traction. But some of it came just because of the machines deteriorated so fast when it came to dust. But he said, in an ideal world, he didn't say in an ideal world because I don't think that was a phrase in Swedish, but he said the belt should always outlast the bearings. Okay, and I think I would echo that sentiment even today. If the machine's been sealed properly, if that joint has been made properly, and that belt has been tensioned properly, the flat belts have got a bad rap over the last 20 years. Probably from 2000 to 2010, there was a fair bit of flack around flat belts, but I think it was for the wrong reason. Okay, the actual technology was a victim of other circumstances or other issues. But I agree, if the machine's been sealed properly and the belt's been tensioned properly, that will actually last longer than the bearings.
Correct.
Because they actually have a very low friction coefficient because they are flat. So they'll sit on the pulleys all day long. They don't generate a lot of temperature because they're flat. So that contributes to, that has other flow-on benefits. All the other components don't need to resist the same sort of temperature.
Now, Tim, unfortunately, you've highlighted a question here, and I can see, I can picture everyone out there going, but they've told me I had to replace my belt. But why? When Tim was talking about the talcum powder between them, well, when your bearings break down, they create a fine dust, and that fine dust does the same thing. So that gets onto your belt. So leaving your bearing changes too long as well can actually come back and affect having to replace the belt at the same time. So a lot of people will be going, but hang on, if it should last, I've done the bearings, and belt 3 times in a row. Why is that? That's a part of the reason is if they're not getting checked regularly, that fine dust builds up within there, it gets onto the belt, and basically it means that we check the belt and say, right, there's a lot of contaminant on there. It's not going to grip how it should. That's why we're saying we should replace it. So just for those who are thinking that at home.
But Hayden, in order to be able to do that, you need to be able to check these things out.
That's right.
And we know a lot of the machines these days don't have any inspection panels or any way of actually assessing the internal health of machines.
Exactly right. I go through a lot of 12mm drill bits, putting them into machines.
Drilling a hole, so you have a camera in there and have a look around?
Inspection camera. Quite a few manufacturers, don't have inspection holes to check any of this internal or to see how clean it is or what's going on, which I think is a really important thing. Like, people say, but you don't have an inspection hole in the side of in the sump of your car to check the bearings. It's like, well, you do. It's called the drain hole. You can do the same thing through there. So, but a lot of manufacturers have nothing to check. You basically have to tear the machine apart to check it. Which is problematic because that's a whole lot of labour to do a small check. So, Anything else you want to talk about on belts?
Well,
I see different materials. We can go on all day on some of these things, Tim. You and I. It's.
Look, I guess these are just examples. This is an original HTC belt. So
it's from the museum, just in case you're wondering.
That's from, I think, a 650 classic machine, 50mm belt. This is from an 820. So I guess that's just an example of the upgrade that we did originally. So we were running HTCs with this. This material, that's a 50mm belt. We ended up with an 80mm belt, so that's over a 50% increase in strength from a width point of view, but we went to a material that was about twice as strong.
Yep.
Right, so I don't know what that works out to. It's probably 100% more, at least 100% more strength in that belt than that way. So what I'm trying to say is flat belts, there's big differences between flat belts. This is another product, okay? Also a flat belt that has a different core. Okay, it has a polyester core. This is a great material for some reasons. One, because you mentioned minimum pulley diameter before. This is a much more flexible material, and it will go around a small. This material, 100 mil is the minimum.
Yep.
Once you go smaller than 100 mil, you start bending that join. You flex it too much, and it starts stressing out the join.
Yep.
This material is a very flexible material. Has a totally different type of join called a finger join. So that join is also very supple and very flexible. So this is awesome because it has high flexibility, very high tensile rating. So
why are we not using it here then?
well, because this stuff only goes up to about 75 degrees as well. So from a temperature point of view, it's right smack bang
With that.
in the same category as that.
Okay.
So if you want to make a machine that uses this type of material, you really have to be focused on making a machine that runs cooler.
Yep.
Okay.
I'll throw that one out the window then.
Well, not necessarily, because we have actually made a machine that runs cooler.
There you go. See, everyone's sitting there going, okay, you've told me about all the old stuff. I'm not here to look at that. What have we got to show them and tell them?
Well, I think let's talk a bit about some of the components. And we mentioned at the beginning of the talk that the original machine was I guess, created within the paradigm of what the existing benchmark was.
Yep.
And one of the goals of the original machine was to make things a whole lot more heavy duty and robust, okay? Like we've mentioned, the industry has grown massively, and the applications that the machines are being used for massively. What we thought was heavy duty back in the late 90s, even our understanding of heavy dutiness has had to go up.
Yeah.
Even then, we obviously with the power, with the big blocks, we went from a 7.5 kilowatt in the HTC, the King Concepts had 11 kilowatts, so we went up 40% in power then.
Yep.
We've gone up another 40% power almost with the big blocks to 15 kilowatts.
Yep.
So we keep creating more power, we're putting more load through the machine, so the parts need to take more
Correct.
rigor. So let's talk about some of the actual parts upgrade from a strength and durability point of view.
Everything's bigger. I mean, just look at it. Much bigger. So this is the I guess the
big head,
the big head, the top plate of the bottom barrel, however you want to call that. So this section here, in essence, there's another plate that would sit on top of here, is replicating what we had over here. Right. So on this you had your small boss there with some small bearings that are over here, and that would sit inside one of these. Whereas now, we've gone a much bigger diameter plate, we've gone much bigger bearings, and a much bigger centre boss.
So this bearing in the past, the whole big head was basically spinning under two of those bearings. Okay, that was it. Okay,
it.
They were the bearings that when you tip a machine back, everything was being lifted up between those two bearings. When the big head was spinning around, it was all spinning around. But for context, HCC had one of these.
Yes, true.
Okay, so we went double when we made the machines originally. This is what we're looking at now from a comparison point of view. So here, this you can just see the black seal. That's one of the bearings. So from a comparison point of view, there's actually another one back behind it.
Yep.
So that's a massive increase, Hayden, in size.
Massive.
Because it's also, not only is it a bigger diameter, but it's a much thicker bearing as well.
Correct.
So we've put a lot of additional strength into this centre boss, centre housing, where we've got these two nice, very heavy duty bearings, and they're also spaced apart more. Okay,
Yes.
so in the old machines, those were all basically sitting on top of each other in this housing.
Yep.
These have now, they're spaced apart more. So
spread the load a lot more.
that gives us a much more rigidity and strength through the whole system.
Yep. What else do you want to talk about on this one? It's big, it's shiny, it's
So there's your coupling. So
this is what Tim was talking about here, is we have our coupling that seats in onto our centre drive that's sitting in there. So that's all sunk in under the machine on this one. So your motor would obviously be sitting up on top of here and beyond. So for removal, it's undo a few bolts on the motor and out it comes. Nice and easy. No seizing on, no chopping things off.
Correct. Look, this metal looks funny to me. It's got a bit of a funny finish on it. This doesn't look like.
I don't want to try and lift it, but they call it lightweight, right? No, so we've gone to an aluminium plate.
Aluminium.
Aluminium.
Aluminium doesn't sound very strong, Hayden.
Well, you know, it's. Well, we have. What are you comparing it against? That's the question. I mean, this, you know, you can't see on the camera here, but you know, it's quite thick. You'll be able to see it on this shortly. I mean, look, you know, when we look at the original heads, we had two plates. They were both 5mm each in steel. Right, so join them together.
We're talking about the shell.
The shell,
okay.
yeah.
The top and bottom plates of the shell.
Which was doing all the lifting work, everything, the compression, the whole lot. So if you take those two, that's 10mm thick. Now, aluminium's not quite as strong as steel, but it's far lighter. So we've taken the 10mm and said, all right, how thick do we need to go? And I think we've ended up with a 20mm thick plate at the end. So effectively, this does have the same strength, probably more at the end of the day than what the earlier versions did on there, and would be lighter as well by a long shot. I mean, when we're lifting these up, we
hand carried that up there.
Yeah.
If that was a 20mm steel plate, there's no way we could have lifted that.
Not a chance. So that's a big change, is we've gone to an aluminium plate. Now, aluminium has pros and cons. From things like tapping threads and things like that, it is a softer material, so you do have to be careful. So a lot of these pulley mounts and things like that, we actually have metal plates sitting under them that do all the compressive work, and anything that has movement is sitting on a metal plate rather than straight to the alloy, because it does wear a little bit more at a faster rate than what steel does. So
it sounds like to me, Hayden, that the shell, or the way that all the parts are housed, have been made differently in this machine.
Very much so.
Would that be correct?
Very much. I mean, there's a shell here, I guess. You know, we've got a top and a bottom here. That's a shell.
So what I'm looking at here is the almost complete grinding head of the 700 size machine. Okay, kind of looks a little bit the same as an original machine. I'm seeing a top and a bottom plate, a side wall. Yep. But there's a difference here.
There is.
What's the difference?
Well, the difference is when
you a bit like baking a cake.
It is,
a roast. You've got to take the lid off and show everyone the lamb roast.
That's right. So the difference is, with our thicker aluminium plate, we've mounted all of our hardware straight to that plate, and we've made it that cover we just removed is under the machine. So essentially, this has a motor connected up to it. You can run this with the
So this is upside down.
It's upside down, right?
So this has normally got grinding heads attached to it.
Yep.
Flipped over on the ground.
Yep.
So this is actually up, and the cover we just took out, the lid, is actually the bottom. Yep.
So yeah, we've essentially mounted everything to this plate. So this all runs on there as it is, and it's very quick and easy to get to. So for inspections.
It's all been made to run off this plate. So all of these pulleys are suspended at one end, and I think we talked a little bit about that when we were talking about the fly pulleys before. All been constructed to run a bit like a wheel in a car, suspended at one end, all mounted to this 20mm very rigid aluminium plate. What's the benefit of that?
Well, you saw how quick it was to pull off, right? Well, now we can see what's going on.
So from a maintenance point of view,
absolutely. From maintenance, inspections,
it's 3 bolts.
Yeah, 3 bolts.
And that plate, that cover we took off before. 3 bolts, covers off, and we're straight into the guts of the machine.
That's right.
No tension to take off.
No,
so what we're seeing a lot at the moment with current machines, we've still got this shell. They call it a clamshell system, where we still have a fly pulley mounted in the top and the bottom of the clamshell. It all goes together, hermetically sealed. Tension the belt once it's all closed up. And then we can't see anything inside, right? If we want to check anything inside, or we want quick access, whole lot of bolts, take the belt tension off, because we literally can't get the bottom of the shell off without with the belt tension still on.
Correct.
Plus there's bolts into the belt tension that would have to come off anyway. But it's probably 15 bolts at least that have to come off.
Easily.
And then some very careful sort of pullers and so forth to get the bottom of the machine off. But you certainly couldn't get to it near as quickly as 3 bolts and off comes the cover.
That's right. And I can hear people out there screaming, but HTC's on a 20mm plate, and it's the same. It's like, it's not the same.
You're talking about the HDX.
HDX, that's right.
The previous model HDX.
Previous model, yeah, yep. But it's still not the same because you can't run that machine with everything connected through a motor and everything live.
So technically speaking, I could pull the bottom of this machine off like we just did.
Yeah.
And you could run this machine on the ground, fully exposed, with that part missing.
Yeah.
And
if you're crazy enough to put demo heads back on, you can grind with that off like that. All right?
Maybe we should try that.
That's a good one. Yeah.
That would be fun to see how long it lasts.
Yeah, absolutely. Once that cover comes off, if this is still mounted through all the other housings on the bottom of the machine, cover is off on site, you're inspecting your machine in 15 minutes.
So obviously there is, I've taken it away now, but on the bottom, we'll call it the bottom cover.
Yep.
Or the bottom part of that shell, there are inspection plates. So you don't actually have to pull this thing off to look inside. There's a few different, or couple of inspection plates where you can quickly, three little screws, take it off, and we can have a look at the internal condition. We can do a little swab, see whether there's some of that carbon dust from the breakdown of bearings starting to deteriorate.
Yes.
We could check for any moisture, could check belt condition, all that sort of stuff. But if we wanted to, and the machine was clean enough and we were happy just to pull that bottom plate off, we could pull it completely off.
That's right.
And we've got immediate access. What would be the benefits of that? Obviously, I'm thinking about if for some reason there was a belt failure, and look, nothing's perfect, it would be very easy to replace that belt.
Oh, very.
Because the belt tension on this machine is very simple to release. And belt comes off.
Right. Yeah, put it back on,
install a new one
in the right direction, and you're off and racing.
Tension it off.
Yeah.
Cover with a bit of sealant back on. 3 bolts, and we're up and running again.
That's right. It's very, very simple.
Would you estimate
for a belt change
to do time-wise in that scenario?
Look, I think if you're on site, I reckon you'd be half an hour. You'd have a belt changed
if necessary.
Yeah. And probably a big part of that is probably cleaning everything enough so that you're not going to end up with a whole pile of dust and dirt inside. It's probably going to take you longer to clean things to a point where you're comfortable to remove it than it is to actually remove it and change the belt. So,
plus we've also made it, you could actually remove these pulleys.
Correct.
If necessary. If for some reason you developed a bearing issue, I mean, not every, it's always ideal to do a rebuild or your maintenance work in a workshop environment, but sometimes you've got machines that are craned up on building sites, nightmares to get them into certain areas, or you've got to book a crane days in advance to be able to get it off again, or you're just stuck and you need to get something fixed. This machine, we can actually replace any of these pulleys on site.
That's right, 3 bolts,
3 bolts
comes out.
Belts obviously taken out first, like you said. So within probably a couple of hours maximum, if you needed to, we could replace all these pulleys with fresh ones, with new bearings and so forth, install, belt back on, close up, and you're up and running again.
Correct.
No need to take it back to the workshop or send it interstate or drive it across town or whatever you have to do to get it to a workshop. If we're at a pinch, one of our technicians could come out and do that, or it's almost simple enough for an actual owner to do it themselves.
Absolutely.
So that's a big change, huge, big change to not just to our original machine, but to other products that are out there on the in the marketplace. Anything else you want to tell us about the internals and the shell side of things?
Well, there probably is, but not that I can think of.
or not that you're allowed to.
Not
talk
that I'm allowed
about.
to. Yes.
Yeah, okay.
Look, there's still, people are going to be saying, but you've still got areas you haven't spoken about. So there are. There's still, we're still designing things, all right? It's I think things are coming in bits and pieces.
We're still making it up, all right?
We're still making it up as we go. No, I mean, look, it's the big with the amount of extra engineering we put into this, and again, this won't show up because not all the parts are here, but everything is heavier duty than what it was in the past. Like, can comfortably say these machines are going to be 10 times more robust than the earlier versions.
So more robust, more simple.
Yep.
So we've tried to simplify not just the way parts are made, not try to reduce how many parts are involved, but also simplify the manufacturing and the maintenance to make it easier. Okay, we're seeing a lot more complexity coming into some of the other machines. We're actually moving in the other direction. Just trying to make it simple.
Make it easy.
But retaining all the really important stuff, the robustness. We haven't even started talking about the powertrain and how pulley ratios and torque and all those sorts of things that that are really key. This is all really good from I guess a manufacturing, maintenance, durability, reliability point of view. But at the end of the day, where we started talking about was this is where the diamonds actually meet the floor. Okay, there's something driving those diamonds, and it comes back to the power and the torque and the ratio and how you create the ratios within those machines. That's probably another discussion for another day. Probably too much to cover here
right now,
but that clearly is another thing that's also been considered. You don't just come up with pulleys this size and ratios and belt wraps and so forth in this particular way. They all have to support what this head is actually trying to do, which is create friction at a diamond tool, concrete or stone or whatever terrazzo you happen to be grinding. It's delivering that power to the floor through the tooling to actually get the job done.
Absolutely, and there's so many factors in that. So many.
So covered a lot today, Hayden.
A lot. I'm hoping people are excited, as we are. Like, there's a lot of cool stuff here.
You thought some of the previous sessions were a nerd out session. Well, this today was the super nerd out session, I think.
And there's still more to come.
I don't know about you, but I'm feeling a whole lot better about this machine. I feel like we've covered up for a lot of the sins of the past here, Hayden.
I'm hoping so. I'm hoping so. I hope people see it that way.
So anyway, I think that's probably a good place to leave it today. And there's heaps more things still to talk about with this machine. But that was a big one. It's an
important one.
Like I said, this is kind of the heart and soul. This is where the rubber meets the road. This is the element of the machine that does all the work, that actually delivers square meterage and essentially money into people's bottom line at the end of the day. So there's been a lot of thought. I think we assembled the first one of these. I think I looked it up this week. It was 3 years ago when we put the first lot of these parts together. So there's been quite a bit of time involved in when we got the first one together to now, and the different things that we've been sort of tweaking and playing with and testing. So it's been a long incubation period.
It has.
But that's good.
That is. Good testing.
Anyway, I'm just wondering where Josh is. He's normally sticking his head in around about now, but oh look, I can see him coming right now.
Yeah.
That makes sense. Hey, how much fun was that? A total inside look at the new grinding machine. We must be getting really, really close to seeing the whole lot come together. I know there's a couple more episodes till we get there, but I hope this is all coming together for you. Thanks for tuning in, and I look forward to seeing you in the next episode.